What is heat? Changes in the state of a system are produced by interactions with the environment through heat and work, which are the two different modes of energy transfer. Heat is the energy transferred due to temperature differences only. It is the energy transferred between substances or systems due to temperature difference between them. It can also alter system states. For example, a stove burner produces heat and conducts that energy through the pot of the water. This increases the kinetic energy of the water molecules, causing them to move faster and faster. At a certain temperature, the atoms have gained enough energy to break free from the molecular bonds of the liquid and escape as vapor. The amount of heat transferred by a substance depends on the speed and number of molecules in the motion. The faster the atoms or molecules move, the higher will be the temperature. So let's define the temperature. It is a measure of the average kinetic energy of the particles in a sample of matter. More kinetic energy means more movement of molecules, which in turn means more temperature. The temperature is actually measuring the amount of energy available for a work in a system. In simple terms, it tells us how hot or cold is the system. It is expressed in the terms of units or degrees designated on standard scale. The most commonly used temperature scale is Celsius. Now, it is important to understand the difference between heat and temperature. Temperature is an intensive property and heat is an extensive property. Recalling that extensive properties are dependent upon the amount of substance while intensive properties are independent of quantity. As an example, consider the difference between boiling a cup of water in one beaker and 10 gallons of water in another beaker. Both samples of water will boil at the same temperature, but will have to heat 10-gallon sample for a much longer time to heat, because you have to put more heat energy into the big sample to get the same change in temperature. Ultimately, the heat energy present in a sample can be derived from the motion of atoms in the object. As the velocity of the atoms increases, the temperature goes up. This is about heat and temperature. Now, let's get to another important concept, work.